Hello and welcome to another video. In this video we're going to be doing another problem and we're going to be doing maximum trailing zeros in a cornered path. Okay, so once again I'm going to kind of take it slow, talk about my thought process, all that stuff, and we'll see if we get somewhere or if I need to look into any other locations. So we have an array grid of m by n and each cell contains a positive integer. Cornered path is a set of adjacent cells with at most one turn. More specifically, the path should move horizontally or vertically if there is one. Okay. Path will move exclusively in that direction. Product of values in path, return the maximum number of trailing zeros. Okay. Horizontal movement means moving left or right, vertical up or down. Okay. Okay, so essentially, if I'm understanding this right, so essentially we can go like, can we start anywhere? I think so. So I think we can start anywhere. Yeah, I mean, technically, yeah. So we can start anywhere and we can go in one direction and we can make one turn and we can stop anywhere. So like if we go here, for example, we can go like here and then like one turn, but we can't go like up and then across or something. So this is one turn. This is one turn. This is, how's that one turn? Oh, okay, this is not valid. Oh, this is not valid too. This is two rights. This is right then down. Okay. Grid left shows corner path product of 18,000, 3 trailing zeros. So let's take a look at the constraints. Okay, so we have 10 to the 5th, which means we need a linear time, meaning like we need an O1 time ideally for every cell in the matrix. So at every cell in the matrix, we should be able to do one calculation ideally, or like an n log n or something. Okay, so let's first think about, let's write some like planning. Let's first think about what it means to like have a trailing zero and how to get a trailing zero. So this is product. So how do you get a trailing zero? Well, it's 10 times something or 5 times something, but 10 is just 5 times 2, right? So to have a trailing zero, assuming these numbers aren't 0, yeah, they can't be 0. So basically the number of trailing zeros is the number of 5s and 2s you have. So every 5 and 2 makes a trailing 0. So for example, if my number has like 3 5s and 3 2s, I'll make 3 trailing zeros. But it's the smallest one, right? So if I have 2 of these, then I'll only make 2 trailing zeros. So basically the number of 10s is min 5s and 2s. And another thing for a trailing zero that I'm pretty sure, yeah, I think it's right. So imagine we have a number with trailing zeros. We can never have less than like, we can never multiply with something and get rid of them, right? Anything that ends with whatever zeros, like x0 times anything, will retain its trailing zeros. So by that means like, let's say we go somewhere and we make a turn. We kind of just want to take the whole thing. So meaning like we want to, if we start here, for example, and go here and go to the end, like we could have taken the 6 and it's never going to make it worse. So if we take the 6, it wouldn't add a trailing zero, but it's never going to make it worse. So let's write that. So min 5s and 2s. And we want to just take full path all the time because it's never going to be worse. Okay, now how do we get every path that's valid? And so if you think about it, so if we're at a cell, what paths can we take? So we can have full horizontal. Just like we're at a cell, we take this whole line with it. Full vertical. And then we can go down to the cell, then left, down to the cell, then right, up to the cell, then left, up to the cell, then right. And then we can go 4 more, I think. So we can go right, then down, right, then up, right, or left, then down, left, then up. Okay, so these are all the paths. So basically, like, let's say we're at this 1. Like we can either take full horizontal, full vertical, or we could start off left, then go up or down. We could start off right. We could start off right, then go up or down. We could start off left, then go up or down. We could start off down, then go left or right, and then up or left or right. Okay. And we need to be able to do this in a one time. So you could do like a prefix sum, but these products, like we want to be able to ideally maintain the number of zeros, and we can't just like multiply. Like we could do a prefix product essentially, where we just multiply the whole thing out. But then the numbers are going to get too big. So instead, what we want to do is we want to store count of 5s and 2s. And we can do a prefix sum of that. So essentially, we can just do a prefix sum for every row and every column of like how many 5s and 2s are there. Yeah. And then, yeah, so essentially like here, there's none, here there's, and to get 5s and 2s, so if we have a number, let's say our number is like 500, to get the number of 5s, we just say like while it's divisible by 5, keep dividing by 5 and add a 5, and same thing for 2s. And that's pretty fast. So the full thing is like the prefix sum will take log to get the factors plus n, or yeah, log n. And then traversal will be all these different paths, which is just 10 times n, so that's just like n. Okay, so the prefix sum will be the same dimensions as grid. We'll make it one dimension bigger to make it one indexed. And we also need one more dimension, or sorry, we'll have it one more length and width to make it one indexed. And we need one more dimension because essentially every cell is going to store the number of 5s and 2s. So every cell is going to have like, or I guess 2s first, then 5s. So that's another dimension. So let's get the dimensions first. Let's make the prefix sum array. It'll be 3D. Okay, so this is going to be one more than the other ones. So rows plus 1, columns plus 1, and 2 for the 5s and 2s. All right, now we're going to fill it. So whoops. Okay. So essentially we're going to say we need to figure out how many 5s there are. So we'll say like, I mean, we could also get that. We can have a helper function, so let's probably do that actually. So private get counts. It'll take a number, and it'll say result to. Right, so while num mod 2 equals 0, result 0 plus plus num divided by 2. And same thing for 5s. Okay, and then return result. So essentially, int array cur count will be the get counts of grid row column. Okay, so prefix sums at row. So remember the well, I guess, yeah, we need to think about this also actually. Yeah, maybe there's a little bit more. So I made this 3D grid, but we need a prefix sum for rows, and then we need a prefix sum for columns. So actually I think we need 2 of these, right? Because we need a prefix sum here and a prefix, yeah, so we'll call this like row prefix sums. Okay. Because we're essentially traversing through the column too. So prefix sums, row, and actually, now that I'm thinking about it, I need to just make it one more for the columns, not the rows. So the rows will be the same. Okay, so prefix sums row column plus 1 equals, so actually this will be 0. So this is the 2's, so cur count 0 plus the previous count of the 2's, so prefix sums row, column, there we go. And same thing for the 5's. Cur count 1. Okay. So that's the prefix sums for the rows. Now we need to do the exact same thing for the columns. So let's do that again. And it doesn't matter if we call get counts twice, like who cares? Okay, so this is going to be the column prefix sums. And now that one, we're going to go for every column, we're going to go down the rows. So this one needs to be increased now. And we need to go the opposite. So for every column, we go down the rows. Yeah. Okay. That part's the same. So this is call prefix sums of row plus 1 column, basically just the opposite. So current count 0, 1, column of row C. That should be the same. Yeah, basically of the current, yeah. So essentially, like for the column prefix sums, like as you go down a row, the index for the prefix sums will be 1 past this. That way the empty array will be over here for the, hopefully that makes sense. It's basically just one indexing, so we don't have like the index out of bounds. Because normally for prefix sums, the index is like the sum up to that index, but if you do that, then you're not including the empty array. And that way this with this we won't have like the index out of bounds error. Okay. So now we're gonna have a result. And now we're gonna go through all of the cells and we're basically gonna get this guy. So we're gonna say, let's go in every direction. So we're gonna try the horizontal, we're gonna try the vertical, and then we'll try every combination of, so we'll do left and then right. We'll calculate those separately, I guess, and then we'll just get the value. That'll make it easier. So let's do that. So well, first, let's go through the whole thing. Okay, so the horizontal is, and we are computing the horizontal multiple times technically. I guess we can do that just here. Yeah, let's just do that here. And then we don't have to do, we can skip that. So we'll say result equals 0, result equals math max. And we'll have a helper function as well. So we'll call this calculate, sure, calculate zeros. And this will take an array. Should it take an array? No, it's fine. Okay, we'll just do math min of, yeah, basically these two. So this guy and that guy. That's how many zeros we have. Okay. And same exact thing here. So essentially result row prefix sums. We probably need the right index though, so do this one and this one. Okay. Okay. So that will give us the horizontal vertical. So we're done with that. Now we need to calculate the left, the right, the left, the right, the top and the bottom, and then we'll just do combinations. So, I guess we could have technically done top and, yeah, maybe that's cleaner. So let's actually get rid of this. So essentially, we'll do every combination of everything. Yeah, so basically what's going to happen here is like we'll calculate everything to the left, everything to the right, everything top, and everything bottom, and we'll do all combinations of those. And those are going to be like the values. So let's do that. Yeah, so we'll just say like int array values equals new int array. So there's 4. Left, right, top, bottom. So we'll even have a little thing here. So left, right, top, bottom. Okay. So let's get the left first. So left. So whatever row and column we're at, we basically just want the prefix sums of, yeah, I guess we need 2 values. So we need left 5s and then left 2s. Or we could do, actually we can do this instead. So we can say int array left equals new int array 2. And same thing for right, top, and whatever. So we'll do this. Okay, so left, right, top, bottom. Okay, so let's just do these one at a time, and then we can. This is a good one where you can put it into GPT and clean it up and see like how could we have made this better. But for left, so basically we want the prefix sum of here. So this is going to be like left 0 equals, and we want rows here. So row prefix sums at this index of the row, at this index of the column, because that'll give us the one before, minus row prefix sums of, and this is actually going to be 0, right? 0 index minus row prefix sums. This is just 0, or sorry, at the row column 0. So that's the left. Left 0. Left 1, it's going to be very similar. Okay. Right is going to be very similar. So left or right 0. So for right 0, we want the last part up until the one right before. So the last part will be, the row is correct. The column needs to be the one after. So that's going to be at columns. Yeah, 0 minus, and then the next one will be, we want everything not including this one. So that's going to be up to here. So that's going to be row prefix sums at row, column. So column plus 1 would have been up to here, but we actually need plus 2, I think. And 0. Actually, so we want to include this. We don't want to include this. So actually it would be plus 1. Okay. And the same thing for the 1. Okay, so this will be, let's see. Oh yeah, just all the same. Okay, so now we need top and bottom, and it's going to be kind of similar. So top and bottom is going to use the call prefix sums. So top 0, it's going to use the call prefix sums. So we do want this column, this exact column, at index 0 minus this exact column at index 0 as well. And now we need to figure out the row. So the row is going to be up to here. So that's going to be this current row, like that, minus 0. Okay, there we go. So that's the top. This current row is going to be the sum of everything up until this. Top 1. Very easy to make a mistake here too, but it's fine. Okay, so now we need bottom. So last one. Column prefix sum. So for the bottom, it's going to be at the very bottom, and we want to, let's see, yeah. That is correct, actually. So for the row, we want, okay. Oh, right, that is correct, yeah. Actually, let me double check. So for the row, or for the column will be the same. Yeah, so we want row minus 0. That is correct, yeah. Okay, yeah, so for the bottom, we want rows here. We want one past where we're at, column 0, minus, and so we don't want to include this value. So we want here to be row, I think. Is that correct? Let's see, rows. Yeah, we don't. Actually, sorry, we want to include everything up until this value. Yeah, so this value is actually at row plus 1. Okay, there we go. And it's the same format as here. Okay. And then bottom 1 is all the same. Okay, great. Now we can add these in. So value 0. So this is the left equals math min of left 0 and left 1. Basically the minimum one of those. And then the rest is all the same. So yeah. Values 1 will be the right and the right. Yeah, this one definitely has a lot of room to like have cleaner code than this. That's for sure. Top, bottom. So this is going to be a great GPT refactor use case. Oops, top. And last. Okay, so now we just have to do every combination of these guys. So that's pretty straightforward. So we can just say like for int I equals 0, is less than 4. For int j equals minus 1, j is less than 4. Okay. This is I. Okay, so now we just do the combination of those plus the number of zeros at our current value. So let's get that as well. So int cur zeros, because we are always going to include our cell, equals, and then we can use our helper here, get counts argc. Okay. Oh, this gives you an array, right? Yeah, int array. So we can actually say int array cur. So this is not zeros. This is like counts or like factors. And then we can say int cur zeros. Cur factor is 0. Cur factor is 1. Okay. All right, that should be fine. Method is not applicable for int. Oh, I need to pass the grid, right? So what is grid? Grid. Okay. Okay, so this is going to give us the zeros, and then we just do this loop. So res equals max res cur zeros plus values I plus values. Actually, yeah. Because basically we're saying we're taking like one chunk out of these, just one, and we're getting all the zeros there, and then we're getting another one. So like, for example, with this will say like this, there's 2 here, and here there is, or sorry, there's 1 here, because only 1, 2, and 1, 5. And here there is 2 5s, and how many 2s? Well, whatever it is, only 2 5s, and there's 2 2s or 3 2s. So this will give us 2 as well. And this is correct, right? So this is like 120 times 15. Actually, this should be a little bit more, I think. Yeah, 120 times 15 is 1800. So there should be, oh, that's right. That's 2 zeros. Yeah, and this is 1. Okay, so might have screwed something up, but let's just see where we're at. Okay. Semicolon. Kind of wordy. Damn. It's gonna be hard to debug, to be honest, too. So that's annoying. But let's just look through it. We're probably missing something small, and honestly, at this point, it's kind of like I would consider this as like problem solved. and just GPT like probably like missed the value or somewhere. So let's just see. Row. Okay, so for the row prefix sums, we basically want one extra column, which is what we have. So we get that. Row prefix sums, yeah, that's fine. Cur count plus, that's fine. That's fine, I think. Then for the call prefix sums, we want one extra row. So call prefix sums, add the extra row. Yeah, looks fine. Okay, so we get our current factors. We get our current zeros. And then we calculate these. So the left is row prefix sums at this row, which is correct, minus 0. That's correct. And then the right is the same, or that's the same. Then the right is row prefix sums are, so the row is correct, yeah. Column 0, that's correct as well, minus this. Or you actually do want to include this, so it's actually here. Yeah, and I think that's correct as well. Yeah, I think that's correct. Okay, so for top, row prefix sums of, so we don't want to include this, so yeah, row column 0 minus row 0, column 0, that's correct. And then for the bottom, so we want rows minus, so we don't want to include this, so this is row plus 1. Yeah, it seems correct. Values 3. And then for all of these combinations, yeah, that honestly seems correct. So at this point, I'm just not going to waste time. Like, it's going to be something small. So let's just take a look. So tell me bugs here. Okay. Let's see. Left, right, and add current zeros. For example, go right from the start, then go down. So I don't think we need, I think we can have, or are we not allowed to do that? Maybe I misread. A password exclusively. Option return if there is one, but there doesn't have to be one. I think. Yeah. So, okay, so this is where I would say, like, okay, so take this. Okay. Okay. Okay, so basically just saying, like, this is fine. Wait, why is it invalid? Vertical straight path. Yeah. Okay. So clarifying, yeah, I think this is pretty dumb. So this is the current cell, so I'm not double counting. Okay. Invalid path. Current zeros plus value 0. Okay, so still kind of not correct. Going in the wrong direction, maybe let's use a better model. So top means all cells above cur cell. Bottom means all cells below. Okay, let's see if you get a better answer, because that was not good. It's kind of annoying sometimes, like I'm probably just missing something really dumb, but it's telling me like my whole result is not correct, which is, I don't think is right. But let's see what it gives you. Meanwhile, let's keep looking, I guess. Yeah, it is difficult to debug this because like for big numbers, right, it becomes kind of impossible if you miss like one like number here or something. But let's see. That this is why typically the AI solutions are good here, because I'll just have like go off by one error or something that it can point out to me. All right, let's take a look. Current zeros, trailing zeros. Oh, actually, I think I realized my mistake. Yeah, I did. So the problem, yes. So the problem here is, yeah, okay. So it wasn't an off by one, and it didn't really point it, well, sorta. But let's say the left side has like 1 and 2, and so I'll just say like, okay, there's one contribution here, and the right side has 3 and like 4 and 3. So you actually need to add them first, then get them in, instead of just getting them in. Because like in this case, we'd have 5 and 5, but I'm getting them in too early. So that's a problem. So let's debug. So this is not correct. We don't need that. We just need the current factors. We don't need this. We don't need all these values things. Let's do an int array, actually. So let's do it this way. And then let's do, let's make this change. So values 0 equals left. Values 1 equals right. This way we can add the values, then get them in, and then we'll be good. So top and bottom. Okay. Now what we need is we need to add up all of these values. So we need to add, we need to make a new array, add up all of these, and then get them in, and then we're good. So let's do that. So int array like cur count. Okay. And so we need to say cur count 0 equals values I at 0 plus values j at 0 plus cur factors at 0. And same thing for 1, so we can just, and then we get them in, and then we should be fine. So 1, 1. Yeah, I think one way to probably clean this up is like make the array at the same time, but it's fine. Okay, now we do cur count 0, cur count 1. So that was my mistake because I rounded too quickly. Okay, let's see if that's correct. Come on. Nice. All right, so now we can definitely say like this is correct. Let's go for a refactor. Okay, so okay, and now we should get like a reasonable refactor. Yeah, that's the annoying thing about the large language model sometimes is you like your solution is basically right, but you're off a little bit, and then it'll just tell you like, oh, your whole logic is incorrect and whatever. So yeah, let's see if we can get something better. And I think here we'll get a quite good improvement, and then the learnings here are going to be like, okay, how could I make this cleaner to not run into these problems? Okay, let's take a look. Yeah, I mean, this is, what is that? What is going on? Why are there just gaps? Okay, well, let's see if it is actually better. What the heck? Up 5, left 5. Oh, is this just like, I think this was just wrong, right? There's no left 5. Or there is? What? What the heck is a left 5? What? How do you even write code like this? Okay, let's instead ask for just a clean solution to this problem from scratch and see if there's something else we could do better. So let's just go new chat. Okay, and let's put it in here. Okay. Yeah, I feel like honestly might be better to do these problems in like Cursor or whatever, so you don't have to like copy paste this, and then you'll get better feedback and it'll be a lot quicker. Maybe I'll do that in the future. Just do these things in Cursor or whatever, like IntelliJ or something. That's probably a good idea, and use the AI thing in there, because copy pasting into prompts is not going to be the greatest. All right, let's see if this is cleaner. I still got these magic like left 5 things, which is weird. But let's see, this looks a little bit better. Okay, so we got the, what the heck is a C5? Oh, count 5, okay. Yeah, interesting. Factor counts for each cell. Okay, so we get the, okay, so essentially they made a new array that's the factors of 2s and the factors of 5s, and they made a new array. That probably would have made it easier to code, to be honest. So you make a 2D array, and then you have the factors of 2s and 5s. So that makes sense. Directional prefix sums. Okay, they use the same exact. Okay, oh, they made it separately. I see. They made it separately, so you don't have to have like 3D arrays. Also makes some sense. Okay. Okay, so they also didn't use the 1D prefix sums. They use the 0-dimensional, and they just manually do the check. Makes sense. Left and up. Okay, but they're like... Yeah, honestly, I don't know if this is better. Like, I feel like it's not. So, I mean, other than... Yeah, I can't say it is for sure, to be honest. So, yeah. So I think the main things is like, yeah, I could have made prefix sums separate for, yeah, probably prefix separately for 2s and 5s. So I didn't have this 3D guy. And I could have made it the same dimensions, but honestly, I don't think there's a big improvement or like any improvement from their solution. So yeah, I don't think that's curious if someone posted a Java and it looks cleaner than mine. I mean, not really. Yeah, I mean, maybe just a messy one in general. I don't know. Okay, but in any case, so yeah, so the time and all that. Okay, so what are we doing here? So we're going through every cell and we're getting the factors. That's n log n, because for a number to get all its factors, it's n log n. Because like imagine, like to get factors of 2, imagine all your numbers are just a big multiple of 2. That's log n. And then all the prefix sums is constant time, so it's n log n for time, where n is the space for the grid. And space is n because we made a prefix sums. So yeah, I'm gonna cut it here. I think. Hopefully this is helpful. Let me know if how I can make this better and so on. But yeah, yeah, I would say for these types of problems, honestly, the main problem I run into is, well, actually here I didn't even have like an off by 1 error or something, which is surprising. I had a logic error. So that's but it's kind of hard to tell because I was thinking it's an off by 1 error, but then I realized like, oh, I'm counting too short. But yeah, it's gonna be all for this one. So thanks for watching.